Hi everyone, welcome to this exercise. In the previous exercise, we compared precipitation data from satellite with rendered measurement to validate satellite precipitation estimate. In cases where we may not have in situ measurements of precipitation and/or evapotranspiration, which is the case in most of the areas covered by WaPOR, we can compare precipitation and evapotranspiration satellite estimates to get some idea of validity of these products. From experience, we expect some land cover classes consume more water than they receive through precipitation. For example, irrigated crops, certain types of trees, and open water bodies are expected to have more evapotranspiration than precipitation, at least in arid and semi-arid areas. In this exercise, we will compute precipitation and evapotranspiration and the difference for each land cover class from land use map. We use the data for Litani River Basin, which is located in Lebanon, for this exercise. So the steps we will be following: first, we read satellite estimates of precipitation and evapotranspiration data for Litani River Basin from an SCDF file. We read land cover classification data for the basin also from an SCDF file. We calculate the mean precipitation, evapotranspiration, and the differences for each land cover class, and finally plot bar charts of the data for visualization. Please make sure you have downloaded the data for this exercise from the course platform and to correct the paths to the input files as needed in the script. First thing we do is to import the required package. Import the required package and get the paths to the netcdf files. We have two netcdf files, one for the yearly land cover classification data and one for the monthly precipitation evapotranspiration data. This data were downloaded from WaPOR and packed into an SCDF file. We use XRA to open and read this dataset, and we can inspect the dataset. For example, for precipitation and evapotranspiration dataset, we have 36 months of time step, which means from January 2016 to December 2018. This dataset contains both precipitation and evapotranspiration data. We can inspect this data arrays individually. So, for example, for precipitation, we have the same time step. The unit is in millimeter per month. Quantity precipitation and source is from WaPOR, and the same for evapotranspiration. We can plot the monthly data for precipitation and evapotranspiration. So, for example, for precipitation for January 2016, the values vary from 75 to 250 millimeter per month, and for ET from 0 to 60 plus some values. We compute the yearly dataset for precipitation and evapotranspiration. So we resample the monthly dataset into yearly, and we harmonize the time steps for the land cover class and the precipitation and evapotranspiration. And we read the code of each land cover class and their description as a dictionary, which is also obtained from WaPOR. Now we have all the data we need to calculate the mean precipitation and evapotranspiration per land cover class. So we iterate through the years and through each land cover class to compute the precipitation and evapotranspiration and their difference, and we save them as a data frame and save into a file, CSV file for each year. So if we run this script, we will get 3 CSV files in the output folder for each year. And if we inspect one of the data frames, for example, for the year 2018, this is how it looks like. We have index column, land cover class description, and 3 columns, one for precipitation in millimeter per year, actual evapotranspiration, and their difference. We can compute the mean of all the 3 years to observe how, for this 3 years period, how the precipitation, evapotranspiration, the difference per land cover class looks like. We get the mean data frame, which has the same structure as the previous data frame. But if you look closely, you will see that irrigated croplands consume more water than precipitation. That means the evapotranspiration is more than the precipitation. And the same is true for some type of forests and for water bodies. We can plot this for visualization purpose and see that irrigated croplands, some forests and water bodies consume more water. That means they have negative precipitation minus evapotranspiration. So by doing so, we have some sort of validation that this precipitation and evapotranspiration estimates from satellite behave the way we expect. This is all about computing precipitation and evapotranspiration, and hope to see you in the next lesson. Until then, goodbye.